Okay, so harnesses like Claude Code and Codex are designed for coding tasks. But people are now using them for a lot more than coding, including all kind of knowledge work. But the thing is that all of this still gets funneled into one harness that was built for coding. And for these non-coding jobs, this harness is not the optimal one. So what if instead of forcing your tasks through it, Claude Code could write its own harness custom for your task on the fly right in front of you? This is what exactly dynamic workflows are. I covered how they're different from agents last time. So today it's all about one idea, a custom harness for every task on the fly. Now, the question is going to be, why even bother building custom harness for every task? When one Claude works on your task, everything it touches lands in that single context window. Now, on a big, messy job, that windows fill up and starts hitting a ceiling. That impacts the performance of your model or agent. Now, there are usually three failure modes that you will notice. The first one is agentic laziness. This is where it quits early and calls the job done after partial work, like a security review where it handles 35 of 50 tasks. The second one is self-preferential bias, where it grades its own work too kindly the moment you ask it to check itself. And the third one is goal drift, where the original brief slowly leaks out, especially after the context gets compacted. Now, the fix for all of these is that stop running the whole job in one context and split it across separate, clean ones. Okay, so a potential solution to this is dynamic workflow. In this video, I want to talk about what exactly they are. For more details, watch my previous video. So it's just a JavaScript file that runs a small team of Claudes. Now, if you break it down, there is a script and it has a few special functions. The main one is agent, which spawns one sub-agent within its own clean context window. Then there is parallel, which pans a bunch of them out at once and waits for all of them to finish. And a pipeline, which streams a list of items through a chain of stages. Now, on top of all of this, the workflow picks which model each agent is going to run and whether it gets its own work tree or not. Also, if it gets interrupted, it can just resume where it left off. Now, if you're a Claude Code user, you might be thinking that you can already do all of these things yourself. So what's the whole point of this new dynamic workflows? So think about a question like this. Should we migrate our checkout services to a new provider? The old way was a static workflow. You use the agent SDK or Claude-P to wire it together ahead of time, so it has to stay generic. Now, it turns that question into 5 web searches and a generic report. A dynamic workflow flips it. With Opus 4.8, Claude is finally good enough to write the harness at runtime, which is going to be custom built for that specific task. So, for example, for the same question, it's going to read your billing code, pricing at your real volume, even argue the other side, and hands you a specific recommendation, which is going to be custom built for this specific task at hand. Okay, so Anthropic just published a very interesting blog post exactly on this specific topic. And they looked at specific patterns, which I'm going to show you in the rest of the video. Now, the beauty of these patterns is that you can implement them in any coding agents. Now, according to Anthropic, when Claude is building these harnesses, there are 6 different patterns that it uses in order to build a custom harness. The first one is classify and act. So in this case, when a new task comes in, a classifier agent decides what type of task this is, and then it routes it to a different agents from there. So you can think that a bug is going to go to a fixer, a question is going to go to an answer, right? And we have seen this pattern. There are routing techniques that people use in order to route different queries. But you can also put the classifier at the very end to shape the final output. Okay, the second is what they're calling fan out and synthesize. So in this case, you can take a task and split it across many agents all at once. Now, each one runs its own context window, so they do not contaminate each other, and hence the biases are not spread across all the agents. Then a synthesize step acts as a barrier. It waits for every agent to finish and merges their results into one. Now, you want to use this whenever each piece of the work needs its own clean context window. Now, this third pattern is what makes it different from agent teams. So let's say one agent, the worker, produces something. Then there's going to be a completely separate agent, which we're going to call the critic. It's going to attack it against a rubric. And the output is going to be only kept if it survives the critique. Now, you can think about this as a direct cure for the self-preferential bias from earlier, because the critic has no attachment to the answer. You usually have a planner, executor, and then verifier with adversarial reviews. Okay, so the fourth pattern is generate and filter. Now, in this case, you generate a whole pile of candidates. Then you run them through a filter. Say it's a rubric or by actual verification, and dedupe the repeats. Now, after this filtering, only the best results are going to come out. So in this case, you're running multiple different hypotheses, testing them, and then keeping only the best. Now, this pattern is great for naming, for design, or anything where taste matters. Okay, so the fifth pattern is tournament. Instead of dividing the work, the agent competes. Now, this one is very interesting. So you spawn multiple different agents that attempt to solve the same task in different ways. Then there is going to be a judge which compares two of them at a time, and the winner advances to the next stage. Now, you repeat this pattern until there is only one champion left. Now, here's the beauty. Comparing two things head to head is more reliable than asking for an absolute score, and it is also how you sort 1,000 items that would never fit in one prompt. So this is a good pattern to use if you want to use these LLMs as a judge. Okay, so the sixth one is a loop until done. And the idea is when you don't know how much work there is, you don't guess a number of passes. So in this case, an agent runs, and then there is a gate or a conditional statement which asks, are there any new findings? If the answer is yes, it is going to create another pass. And if the answer is no, then it's going to be done. So the loop decides when it finishes, not a tired context window. And that is the cure for agentic laziness. Okay, so in the last video, I said that this works great for coding tasks, which is true, but I was kind of wrong on the premises that it's not going to work well if the task is not well defined. According to Anthropic, it does work. So some of the examples that they have presented in the blog post is ranking resumes during a hiring process and looking for, let's say, the top 10 candidate. On the strategy side, it can tear your business plan apart into 3 different angles. I'm going to put a link to the blog post where you can actually see some example prompts. Now, you can also use this to improve your own coding agents. So for example, you can ask it to mine my last 50 sessions and turn the corrections into Claude.md rules. Or some people are using it to analyze messy operation like dig through 6 months of Slack and find root causes nobody filed a ticket for. Now, these are not coding examples, but seems like you can use dynamic workflows for tasks like these. Now, the beauty is that each one of those jobs maps onto one of the patterns we just covered. So for example, verification is one agent pulling every claim out of a document and another checking each one. If you look at triage plus quarantine, so triage is classifying and deduplication of backlogs with a neat security trick called quarantine. where the agent reading untrusted contents are not allowed to act on it. Now, another example would be sorting 1,000 support tickets. That basically becomes a pairwise tournament. Similarly, root cause work generates hypotheses from separate piles of evidence with a classifier that can even pick which model to use. Now, the beauty is that dynamic workflows can generate specific harnesses for these tasks on the fly. And also, you can reuse those harnesses again. It's not that once you use them, they are gone. They are artifacts that are going to be within your Claude. Okay, now I covered how exactly you can use this in my last video, but you can simply ask Claude and say like ultra code or workflow, and it's going to trigger it for you. There's another thing. You can cap the cost right in the prompt, something like use only 10,000 tokens. And you can also pair this with /loop or /goal to run it on a schedule with a hard finish line. Okay, but before you go there, this is going to burn through your tokens. And most tasks don't need a panel of 5 reviewers. So always ask yourself whether the job really needs more compute or it can be done with a simple agentic pattern. Okay, so let me show you a quick example of this. For more detailed demonstration, I'll highly recommend to check out my last video. Let's say we want to rank 80 different resumes. Now in the prompt, you just need to include the keyword workflow, and it's going to automatically dispatch a workflow for you. The workflow basically is a custom harness for this specific task. And you can try multiple of these, and then whenever you get the best one, you can just save that. And that becomes your custom harness for this specific task. Now, one problem with this is that if you actually want to use the word workflow in some other context, Claude will usually misunderstands it and will trigger a workflow, which I think is a really bad design pattern. They shouldn't be including these things in the system prompt, or at least should have special tokens for them. The other way you can do it is just go to the effort and set it to ultra code. That also triggers the workflow. Now, for the last couple of years, we have had one harness specifically designed for coding, and we have pushed it through everything else. Dynamic workflows let Claude build a new one for each task, as I showed you in this video. And I think this is a pattern that we're going to see more and more, especially when these companies are pushing for building super apps. Now, to be honest, we don't know all the best uses yet. So try it out on messy non-code work you have been forcing through a coding tool and see what happens. But keep in mind, the token cost is going to be pretty dramatic. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.